Welcome back. My name is Mr. O, and today I'm going to be teaching you the SAT Practice Exam 1, Section 3, Math, specifically numbers 19 and 20. We do have the problem solved already for the prior questions, so feel free to watch those videos, but specifically today we're going to be looking at number 19 and 20. And usually when I do these problems, I'm just going to do them real quick and then explain the problem in depth afterwards, which is also provided in the bottom of the video. And so, for example, 19. Now I'm going to solve it. So, in the right triangle, okay. Oh, the answer is going to be 4 over 5. Now I'm going to explain to you how I was able to get to the answer. And for this question, it does seem as if I just copied down what is already written on the problem, but there's a piece to this that you have to understand. And so the question asked me mainly, if I have sine x equals to 4 over 5, it says, what's cosine 90 minus x? Question mark. The part is this. This is a trigonometric rule. So trigonometric rule, or it's more like the property of trigonometry. It's not per se the identities, which is another whole concept in itself. It's more about the idea of what does sine and cosine do. And so this is the important thing you must understand, is the fact that usually when we work with sine x and we work with cosine x, we understand that whatever the degree values for sine x and cosine x is, they will end up balancing each other out to get to the final answer. So what I mean by that is that they usually balance out and end up equaling to 90, dependent on the values for the degree. So if I have, for example, sine of 30 degrees, that is going to be same thing as cosine 60 degrees. If I have sine 45 degrees, it's going to be the same thing as cosine 45 degrees. The important thing you must note, and I'm going to show them in different symbols, is the fact that their degree values will always add up to 90 degrees. And so for this question, when I saw sine x equals to 4 over 5 and I saw sine 90 minus x, it automatically told me that this and this are going to be exactly the same value. And thus, I know right off that the final answer is going to be 4 over 5. Since if sine x equals 4 over 5, and I know that whatever degree value this is that subtracts, they're going to still share this complementary property, aka that they end up adding up to 90 degrees, and thus that concludes my explanation for number 19. And to continue on to number 20. So it states this, okay, so a equals to 5 over 2, 2a equals to square root 2x, so I'm going to plug that in, so 10 equals square root 2x, okay, well, 200 equals square root 2x, x equals to 100, okay, x equals to 100. Okay, so my final answer for this question is x equals to 100, and now I'm going to explain to you how I was able to get to this answer real quick. So for number 20, it states if a equals to 5 root 2 and 2a equals to square root of 2x, what is the value of x? That is your end goal. And so when I'm doing this question, I thought, well, I'm not exactly sure how to solve for x right now. Well, I could exactly do a substitute a out and try out what happens. So I'm going to do that. So I'm going to replace this a with 5 root 2. So 2 times 5, or times 5 root 2 equals to square root 2x. And I know that based on the properties of multiplication, you can only keep the outside stuff multiplied. You can't multiply inside it. So it'll be 10 root 2 equals to square root 2x. But I noticed that everything's in the square root right here. And so I'm a little bit bugged because this 10's outside right now and there's nothing outside for this square root or this equation. And so I want to do is force this 100 back inside this square root as if it was not simplified so that I could solve for x. And I know that because if I bring this 10 inside, it's actually going to be me doing 100 times 2, because 10 times 10 is 100, and thus if I want to simplify this, I could pull out 10 out of this, but right now that's not my goal. And so when I do that, it's going to be square root 200 equals to square root 2x. And thus when I was able to get to this point where it's square root 200 and I have both sides square root, I could actually get rid of the square root. The way that how that works is the idea is that I squared both sides and the square root disappears, and thus I could simply solve it out. And I know my final answer is going to be x equals to 100. And that is my end goal, to solve for x. And thus, my final answer is 100. Thank you so much for watching. This concludes the series for specifically the Section 3 Math. We will now continue on to the Section 4 Math, where I'll solve out the problems as I've usually been doing. Thank you so much for watching. Please follow us on Facebook or YouTube, and hope you have a wonderful day.